Welcome, geometry students, to the homework help video, page 617, numbers 3 through 20 and numbers 32 through 34. Hopefully you can get a little bit of help today on your homework if you're struggling, okay? Let's take a look first of all at numbers 3 through 8. The directions say to find the measure of the blue intercepted arc, okay? Find the measure of the blue intercepted arc. Now, here's the blue arc right here. You can look in your book and see it if you need to. And that's not blue, there's blue. There's the blue arc right there. Now, remember, if 20 degrees was your central angle, if you had the angle right here in the middle, and this was 20 degrees, then your arc would be 20 degrees. But it's not a central angle, it's an inscribed angle. Here's your 3 points all lying on the circle. And what we learned yesterday was whenever you have an inscribed angle, the angle is always half as much as the arc, or you can also say the arc is always twice as big as the angle. So if the inscribed angle is 20, then the intercepted arc will be 40 degrees. Okay? All right, moving on to number 4. Same thing. Notice you have an inscribed angle. You have the end point of the angle here on the circle, the end point here on the circle, and the vertex on the circle. Notice you have a right angle right here, and so this would be 90 degrees. So the intercepted arc goes from here to here. And so if this is 90 degrees, then the intercepted arc would be 180 degrees. Okay? Moving on, twice as much, okay? Twice as much. And I just spilt a little water here, so hold on one second. All right, there we go. And let's continue on. Okay, number 5. Now, again, we have an inscribed angle. Here's the end point of one of the lines. Here's the vertex. Here's the other end point of the segment of the angle. And notice this angle here is 105. So if this inscribed angle has a measurement of 105, then the intercepted arc that this inscribed angle intercepts is going to be twice as big. And so 105 times 2 would be 210 degrees. Okay, number 6. Okay, we have an inscribed angle. Notice the end point of the segment of the angle is here, the end point of the segment of the angle is here, and the vertex is here. Now we're kind of going backwards, okay? Actually, the directions change now. We're on 6, 7, and 8, and the directions state find the value of the variable. So now we're looking for the angle. So here's an inscribed angle of x degrees, and here's the intercepted arc right here. Here's the intercepted arc, and notice the intercepted arc is 230 degrees. Now remember, the intercepted arc is always twice as big as the inscribed angle. So if this is 230, cut that in half, and x has to be 115. Okay, moving on to number 7. Okay, here we go. Let's think this through now. Let's see. We have, should be a couple different intercepted arcs here. And let's see what we have. Okay, sorry students, took me there a second. This is a pretty tough problem, so I hope you'll really pay attention and listen, okay? Now, it looks like this 75 degrees right here is going for this angle right here. I'm going to highlight it for you. See that line right there, and then this line right here. Okay? So the 75 degrees is for this angle right here. Now that is an that is an inscribed angle. Do you see it? Here's the end point of the angle, here's the vertex of the angle, and here's the end point of the angle. Do you see that? It is an inscribed angle, and this angle right here is 75 degrees. Now, my question to you is, what is the intercepted arc? Well, we do know how to find that. If this is the end point of your angle, which it is, and this is the end point, then the intercepted arc is always the distance between those 2 points. So, for the inscribed angle that measures 75 degrees, there's your intercepted arc. And notice what we're calling it. We're calling it y. Now, remember, students, an intercepted arc is always twice as big as the inscribed angle. So if the inscribed angle is 75, then this intercepted arc must be 150 degrees. So y equals 150. Now let's take this a step further here. Okay, I want to show you something that's really important. Okay, now I'm going to erase some stuff here. And now I want to highlight this arc again. This arc that went from here to here was 150 degrees, okay? Now, look what they're asking us to find. I'm going to get my red marker out. Please watch this, students. They're asking us to find the measurement of this angle. They're calling it Z. There's angle Z. I've highlighted it in red for you. Do you see it? There it is. And notice the endpoint of one segment is here, the endpoint of one segment is here, and the vertex is right here. So we have an inscribed angle Z. And look at this. Hey, look, here's your inscribed angle right here. And for that inscribed angle, what's the intercepted arc? This is right here. And that intercepted arc is how much? 150. And remember, an inscribed angle is always half as big as its intercepted arc. So if this is 150, then angle Z has to be 75, half of 150. Pretty tough problem. Let's take a look now at number 8. Okay, now this goes along with a theorem that we learned that said whenever a quadrilateral is inscribed in a circle. Now look, we have a quadrilateral inscribed in a circle. First of all, it's a four-sided polygon, so it is a quadrilateral. Secondly, we know it's inscribed because all four vertices lie on the circle. And what we learned is whenever you have a quadrilateral that is inscribed, the opposite angles are supplementary always. So if this is 85, then X right here would have to be 95 degrees because 85 plus 95 is 180. Okay, so X is 95. Now look at your other two opposite angles. They are also supplementary. So if this is 80, then Y has to be 100 because 100 plus 80 is 180. So again, whenever you have a quadrilateral that is inscribed in a circle, opposite angles will be supplementary, okay? Now let's take a look at numbers 9 through 14. The directions say find the measure of the inscribed angle, okay? Of the inscribed angle. So here we go. The angle that we're trying to find is this angle right here. We'll call it X. And so here's the angle, and here's the rest of the angle. And notice I have a point here, and a point here, and a point here. So the arc that's inscribed would be right here. And so the, I said inscribed, sorry. The arc that's intercepted would be right here. And so the intercepted arc is 110. The angle will be half that. And so half of 110 is 55. Number 10. All right. Here is our inscribed angle right here. There it is. Okay. Now that inscribed angle has an intercepted arc right here from A all the way down to C. Now the intercepted arc is 218 degrees, and the inscribed angle is always half of that, so half of that would be 109 degrees. Moving on to number 11. Okay, here is our inscribed angle running along to here and then running down to C. There's my inscribed angle. Now the arc that is intercepted is this arc right here. And notice that intercepted arc is 180. So if you cut that in half, then that means this angle right here has to be 90 degrees. Okay, number 12. Here is our intercepted arc right here, or excuse me, I'm sorry. Here is our inscribed angle right here. And that inscribed angle has an intercepted arc that runs from L to N. Okay, now the measure of that intercepted arc is 68 degrees. So we're going to cut that in half, and that means this angle right here is 34 degrees. So the answer is 34 degrees. All right, number 13. Here is your inscribed angle. I always emphasize those 3 points that should be on the circle when you have an inscribed angle. Always make sure that's true. All 3 of those points should always lie on the circle. Now, the intercepted arc for that inscribed angle is from P to R. And the measurement of that arc is 134. So if you cut that in half, you will get 67 degrees. So the answer is 67 degrees. All right, number 14. Well, here's your here's your inscribed angle right here. And so since that's your inscribed angle, then here would be your intercepted arc from U all the way around to S right there. Now the measure of that intercepted arc is 238. So we're going to cut that in half and we're going to get 119 degrees. Okay? 119 degrees. All right. Moving on now to numbers 15. Let me look at the book here. 15 through 20. Find the measure of the arc. So now we're going backwards. Okay? Okay, find the measure of the arc. Now, here is your inscribed angle right here. I'm highlighting it in blue for you, okay? There's your inscribed angle right there. And notice the measure is 32 degrees. Now, the arc, the intercepted arc, runs from C to B. And remember, the arc is always twice as big as the inscribed angle. So if the inscribed angle is 32 degrees, then the arc is going to have to be 64 degrees. All right, moving on to number 16. Here's your inscribed angle. Starts here, goes down to here, and then over to here. So there's your inscribed angle. Okay, now the intercepted arc for that inscribed angle runs from B down to C. Okay, so if your inscribed angle is 78 and you multiply that by 2, you will get 156 degrees. So the measure of the arc, the intercepted arc for the inscribed angle, is 156 degrees. Okay, number 17. Here's your inscribed angle. I'm going to make this just a little bigger, I think, to work with would be helpful. There we go. Also, it's a little blurry, so hopefully that'll help. Here's your inscribed angle. And of course, your intercepted arc for that inscribed angle runs from B all the way down to C. So if the inscribed angle measures 114 degrees, multiply that by 2, and you will get 228 degrees, which is the answer. All right, number 18. Let's see, here's your here's your inscribed angle right here. Okay, and if that's your inscribed angle, then your intercepted arc would run from R all the way to T. Okay, that would be your intercepted arc. And if the inscribed angle is 120, multiply that by 2, and the intercepted arc would be 240 degrees. Moving on to number 19. Your inscribed angle from 19 would be, put a point there at P, your vertex is Q, and then a point at N. There we go. There's your inscribed angle. Now, if that's your inscribed angle, then your intercepted arc runs from P down to N. And if your inscribed angle is 50, multiply that by 2, and you'll get 100 degrees. So your intercepted arc measures 100 degrees. All right, moving on to number 20. Now, your inscribed angle would have a point here at X, and then here's your vertex right here at Y, and then here's your other point at Z right there. Now, if that's your inscribed angle, which it is, then your intercepted arc is going to run from X all the way down to Z. Now, it looks like your inscribed angle has a measurement of 103, so if you multiply that by 2, you will get 206 degrees, which is the right answer. So the measure of the intercepted arc, excuse me, is 206 degrees. Okay, let's take a look now at numbers 32 through 34, and the directions say find the value of X and Y. Okay, now in this problem here, we remember that whenever we have an inscribed quadrilateral, which we do have an inscribed quadrilateral, opposite angles are supplementary. So if this is 114 degrees right here, then X has to be some angle so that when you add these two angles together right here, they equal 180. Well, it would be 66 degrees because 66 plus 114 is 180. So X equals 66 degrees. Now, let's look at these two angles right here. If this angle is 92 degrees, then obviously this angle right here would have to be 88 degrees. And all that I did was I took 180 and I subtracted 92 degrees. And I got 88. So 88 plus 92 is 180. So y has to equal 88. Number 33, same problem. Notice we have a quadrilateral that is inscribed inside the circle. Okay, so we have a vertex here and here and here and here. Now, whenever you have a quadrilateral that's inscribed, opposite angles are supplementary. So if this is 102, then y has to be 78 degrees, because 78 plus 102 is 180. So y has to equal 78 degrees. Now let's take a look at these two angles right here. This angle is 100, so I go straight across. We know x has to be 80, because 100 plus 80 is 180 degrees. So x has to be 80. Okay? And number 34, last but not least. Now this one here is going to be a little confusing, but see if this makes sense. Just watch, okay? First of all, do you notice we have a quadrilateral that is inscribed inside the circle? So we know that two angles, the angles that are across from each other, have to be supplementary. So with that in mind, if angle A right here is 115 degrees, goes straight across, this obviously has to be 65 degrees for x, because 115 plus 65 is 180. So there's one answer. X equals 65. Now let's talk about y. And of course, you might be saying this is not possible to do because I don't know this angle or this angle, but hold it. Notice something about these two angles from here to here, these two angles. Notice they're congruent. There's a red mark here and a red mark here. So we know these two angles have to add up to 180, and we know they both have to be the same. Well, students, it has to be 90 and 90. There's no other two numbers you could have. They have to be the same, and they have to add up to 180. Well, the only two numbers that are the same that add up to 180 would be 90 and 90. So the answer to y has to be 90. Okay? I hope this homework help video has been a help to you. Call or email if you have any questions. And again, we're just reviewing that an inscribed angle's measurement is always half as big as its intercepted arc, and the measure of an intercepted arc of an inscribed angle is always twice as big as the measure of the inscribed angle. And then also, when you have an inscribed quadrilateral, the opposite angles will always be supplementary.